Hello guys and welcome to the 21st video of our Python playlist, and in this video we will discuss our third sorting algorithm, that is the merge sort. Merge sort basically deals with divide and conquer strategy. What happens that we have a list or an array and we break down that list such that we have every element individual. Like, for example, if we have a list 5, 4, 3, 2, 1, we will apply a recursive algorithm such that after at the end we will have every element separate. So let we discuss how it works. So let's say we have a list that is 5, 4, 3, 2, 1, and 0, and we have to sort this. What will happen? We will break this list now from the middle, right? After breaking the list, our list would look like 5, 4, 3, and 2, 1, 0. Afterwards, we will break 5, 4, 3 again. So what will happen? This will be 5, then 4, 3, and here it will be 2 and 1, 0. Then what will happen? The recursive algorithm will be applied again, right? And then what will happen? It will be 5, then 4, then 3, and here it will be 2, 1, and 0. So this is how we are dividing this list. Then what will happen? We will compare each individual element with each other. Like 5 will be compared with 4. It is referred as left side. What will happen? 5 will be compared with 4, and as we know 4 is lesser than 5, so we will make a new list, that is the result, and in that list we will have 4 and 5 placed. Afterwards, now if we go back, so our list is like 4, 5, and then we have 3, then 2, 1, and 0. Then we will do the same work with 3 now, but this time 3 will be compared with both 4 and 5. Now what will happen? This will be 3, 4, and 5. Like 3 will be compared with 5, and 3 will also be compared with 4. So now we will have the elements 3, 4, and 5 in the list. So this is how then what will happen, that this was the left side, and now this is the right side of the list, and here we will apply the same 1, 2, and then we will have 0. Then what will happen? 3, 4, 5, and here we will have 0, 1, 2. Okay. Then then what will happen? Now we have to compare this list, every element of this list, with every element of this list now. Okay. Then what will happen? 0 will be compared with 3, as 0 is lesser than 3. So what will happen? We will have 0, 3, 4, 5 in the list, and here this is the result basically, and here we will have 1 and 2. Then what will happen? That 0, it will be 0, 1, then 3, 4, 5, and rest is 2 over here. Same goes here, as 0, 1, and 2, then 3, 4, and 5. This is how the merge sort works. So let me go back to the code and let me take a list now. So L is equal to 5, 4, 3, 2, 1. Let me make a function def merge sort, and here we will pass the list, and then what will happen? If length of list is lesser than or equal to 1, then we will return that list. Else, what will happen that, as I told you guys, that the merge sort works with divide and conquer. This means that we have to divide the list into further paths. So to divide, what we will do, we will write mid is equal to len, and mid is equal to len list, length of list divided by 2. So after finding mid, what we will do, we will make the partition. Like our left side will be starting from the first index position towards the mid, and then we will find the right side also, that is from mid towards the end. So this is how our list will be divided. So now we will call the merge sort function again, and in that we will pass the left side first, and then we will pass the right side. Now what it is doing, the left side will be partitioned first, and then we will be partitioning the right side. This means that uh, firstly our left side will be sorted, and afterwards our right side will be sorted. So this means that the left part will be further divided into left and right, and then after the left side will be sorted, then our right side will be divided into left and right, so on until we get toward our base case. Now what we have to do? Now basically we have to apply our sorting algorithm. Sorting algorithm means that on what basis our list will be sorted. So what we discussed previously, that as we get the individual lists, so refer them, the first element may be like this 5 as and this 4. Refer this 5 as the left side and this 4 as the right side. So what we have to do is we have to take three variables I, j, and k. They are all 0 now. So the purpose of I is that it is the counter or index of the left side, and this j is counter or index of right side. Now, and this k is the counter or index of the sorted list. Now what we will do, we will see that length while I is lesser than the length of L, and j is lesser than length of M, length of R, the right side. What we will do, if L sub I, this means that this one, that the left side index is lesser than the right side, first right side j, what we will do is that we will add in the index position k of the list, of the sorted list, that is equal to Li, and then what we will do, we will increment I and we will increment k, or we can increment k after the next condition, that is else. Then what will happen, the other condition is that L index position k is equal to right index position j, and then we will increment j. So what will happen in this case? What will happen in this case that uh, look, L index position 0 is referring towards 5 and R index position 0 is referring towards 4. Now what will happen that because it is because 4 is lesser than 5, so we will enter 4 in this list. And now we have capital left still here, that is 5, right? Now what we will do, because we have the 5 element left, here I should first increment k, because after every if condition we will either if condition is true or the else condition is true, what will happen, we will add a new number to our result. So now what we will do, while I is lesser than length of L, look, we still have we still have 5 left. 5 is not added to the list, right? So while I is lesser than capital L, the left side, what we will do, we will add the elements of the left side to our sorted list. So L sub k is equal to L sub I. L means left sub I. Then we will increment both of them, and what this loop do, it basically add all the remaining elements which were remained in the list. They will be added inside the final sorted list. So we have to write the same loop for j now. While j is lesser than length of r, what we will do, we will enter that element into our list with r sub j, and then we will increment not only k but also j. So if now let me discuss again what happens. We know that merge sort deals with divide and conquer. We are dividing the list into parts, into parts, into parts, right? Until unless we get in this position, like every element is individual now. Then we compare elements by elements, list by list, so that we can sort our list. And in this condition what happened, that our left element was still there, but our right element, this 4, was entered into the final list. So what happens after this loop, basically we will get 5 into our this L. So here it goes. Now let me comment this all here, and now let me run this merge sort, and I should pass L over here, print L. So print the unsorted list, that is L, and then we will write the sorted list, that is L again. So if I print all, so you guys can see that 54321 was the unsorted list, and the sorted list is 1 2 3 4 5. So this is how our merge sort works. So I hope that you guys got the concept of how we divide, how we are comparing, we are making basically individual lists, and one list is referred as the left side and the other is referred as the right side. So see you guys until the next video. Take care. Goodbye.